this one. Find the maximum distance between y equals minus x plus 2 and y equals x squared minus 4 for negative 3 is less than or equal to x is less than or equal to 2. Okay? Pretty much like one in the book, but find the maximum vertical distance. Forgot that word. That's an important word. We'll do that other in just a second, but find the maximum vertical distance between those two things. Well, let's first of all just look at the picture, the graph of these two things. This is a line, of course, vaguely resembling this. Let's see, we got a y-intercept of 2 and slope of minus 1, down 1 and over 1, down 1 and over 1. Of course, you can plug them in on your calculator too there to see, but it should get something like this. This one is a parabola. 1, 2, 3, 4. Y-intercept of 4 and x-intercepts of 2 and negative 2. All right, so something like that is what we're looking at. Now, do a little better here. Obviously, picking this, notice, because that's where the two graphs, that negative 3 point would be here, and the positive 2 point would be here. So I'm looking, at this at this part here in the middle. I'm wanting to find the maximum vertical distance between those graphs. All right, well, again, I'm looking for a maximum, right? And so to find the maximum distance, maximum vertical distance, I first of all need a distance equation, right? What would be the distance equation here? Well, if you think about it, what I'm looking at, I think the easiest part to see here, what this is talking about is let's look at this side over here. What I'm talking about is I'm going between vertically, just straight up and down, between these two graphs. I'm looking at that distance, okay? I'm looking at the distance from that line down to the parabola. That's the distance I'm talking about, the vertical distance. Well, what kind of equation would that be? Wouldn't that be, finding that, wouldn't that be the change from, and I don't think it's quite down to that, so wouldn't that be the change in the y's, the difference of the y's? Difference of the y value. So this vertical distance is just the difference of the y values. The y value of the line minus the y value of the parabola. So D here, how would I describe that? The difference of the y values? Well, here's my y values. In each case, the y value of the line will be minus x plus 2 minus the y value of the parabola, x squared minus 4. Now, I should point out here that if it had been the parabola on top, I would reverse those, right? It's the top y value minus the lower y value. So in this case, it's the line minus the parabola. But anyway. Okay, so there's my distance equation. I guess I could simplify it a little bit. It's minus x plus 2 minus x squared plus 4. And so that, putting them in order here, minus x squared minus x plus 6. With me on that. That's the distance formula that I would have in this case for vertical distance. Well, I want to find the maximum vertical distance there. How do I do that? Where do the maximums or minimums occur, depending on the function you have? The critical numbers. And where do the critical numbers occur? Well, it's where the derivative equals 0 does not exist. So I need to do the derivative, right? So d prime this, so that would be minus 2x minus 1. Critical numbers, set that to 0. Be the way to find them here. So what does that give me? Be negative 2x if we add 1 equals 1 divided by negative 2. So the x would be minus a half. So that's, what is that? That's the x value at which the maximum occurs. And so the maximum, it wants me to find the maximum distance. So what's the maximum distance? Well, plug x to be negative a half into the distance equation, right? So it'd be negative, that'd be negative a half squared minus negative a half plus 6. That'd be my maximum distance. So that'd be negative, that'd be 1/4. Minus minus makes a plus a half, plus 6. And so that maximum distance, see that's 2/4. So you have minus 1/4 plus 2/4 plus 6. I believe you're going to get there because that and that's a 1/4, so it's 6 1/4. Or 25/4. It's the maximum distance. Does that sound okay? And it occurs, look where it occurs. It occurs at x equals negative a half, so it's right along in here where that occurs. And that seems pretty accurate, doesn't it? Even my graph may not be that accurate, but it does seem like that's a pretty good guess there. Okay? All right. Now, the next one is similar to it, but different. Let's see why. Is that okay? Questions or concerns? All right, next one. Find the point on the line. Um, 3x minus y equals 5. That is closest to the point 1, 2. 1, 2. Find the point on that line, 3x minus y equals 5, that is closest to the point 1, 2. The one thing we're looking at closest anyway, but very similar in that we do need to find a distance equation. And let's think about the graph here, and we kind of get an estimate of what it might look like, what it might be anyway too. But we can definitely get it right on the dot here. So there's my point 1, 2, and then 3x minus y equals 5. For a number of reasons, I might want here to get this solved for y. Yeah, if it's not solved for something, y in this case, I would probably want us to do that. Might be a good idea to do that. So if I solve that for y, what do I get? Well, the easiest way would be to swap the 5 and the y out there. That'd be 3x minus 5 equals y. So y equals 3x minus 5. Okay, that helps me graph it too, because that's y-intercept of negative 5. Rise and run 3 to 1. So anyway, yeah, there it is. So here's what I want to do. I want to take a point, and it looks like it's going to be a point somewhere close to there, but it doesn't matter where. So this point 1, 2 And this point on this line, x comma y on that line, I want to find the closest such point, the closest xy point I can. How do I do that? Well, again, I'm going to need a distance equation. However, we're not talking vertical distance here. What I'm talking about here is distance between points. And hopefully, you've seen this distance between points formula before. Does anybody recall? Well, it turns out it's the square root of x1 minus x2 squared plus y1 minus y2 squared, or something there like it. You can switch the x2s and x1s out. Seen that before, right? Okay. I want to minimize that distance. Now, here's the story. Of course, this is my x1 and x2 points, right? X1 and y1, x2, y2. That's just the 2 points. X1 and y1, call that the first point. X2, y2, call that the second point. And that's what I'll just call this one my x1, y1, and this my x2, y2, right there, and just plug those in. So that would mean d equals the square root of x1, so that's just going to be x, minus x2, which is 1 squared, plus y1, which is y, minus 2 squared. Is this okay with me so far? Okay, well, again, the only problem with that is, I want to minimize that, which is square derivative. The only problem with it is I've got a y also with an x, so I need to get rid of the y. How do I do that? Well, that's again why you might want to get this equation solved for y. Can I substitute this for y here? Yeah, so just go ahead and plug that in for my y. So I have 3x minus 5. Don't forget the minus 2 comes with it there. So I'll end up with this. X minus 1 squared plus 3x minus 7 squared. And I need to do the derivative. Now there's a couple of pointers here as to how to get the derivative of that. I would go ahead and square these two out. You know what I mean? X minus 1 squared, x minus 1, or however you want to get that. Yeah, square those out. So that'll get me d equals the square root of. That'll be what? X squared minus 1x be minus 2x. Then minus 1 would be plus 1. And then the same thing for 3x minus 7. Do it twice. So that'll be 9x squared minus 21x minus 21x plus 49. So you get to 9x squared minus 42x plus 49. And then you can combine like terms, which would be 10x squared minus 44x plus 50. Okay. Pointer number 2. I'm going to do the derivative. And so how am I going to do the derivative of that? What rule? It's chain rule. So let's write that as not square root, but 10x squared minus 44x plus 50 to the 1/2 power. Right? So now I can do the chain rule pretty easily. All right, so I'm going to get the derivative here. Yeesh. I know I'm going to need more room than that. Maybe I can get it. Okay. So the derivative, chain rule, says do the power outside. So it'll be 1/2. The inside stays the same. x there. Then subtract 1 from the power, so we have minus a half. Then what? Multiply that by the derivative of the inside, which the inside the derivative would be 20x minus 44, right? Is that okay? Now I need to find the critical numbers. Set it equal to 0. It's really not that bad, actually. Let me rewrite this. Remember, these minus 1/2 powers, we really like to flip those over. And so this part becomes, it'll be 1/2 times, and that'll go on the bottom there. And it's to be the square root of 10x squared minus 44x plus 50, right? That'd be in the bottom. And then this, let's go ahead and just write it all together. Actually, I guess I could cancel those 2's out, but you with me that I can rewrite this derivative this way? I can just rewrite it as 20x minus 44. This will be on top, and then 2 over the square root. That'll all go on the bottom. All right, so where do the critical numbers occur? The critical numbers occur when that equals 0. Let's think about that. Well, that equals 0. If I cross multiply, what happens? Well, that's 0 over 1, so that's one way to think of it. That times 0 is 0, isn't it? And then 20, that times that is 20x minus 44. So that set to 0 just turns into this equation. It's not at all that equation at all. Add the 44, divide by 20. Reduces by 4, so it'll be 11/5. Now, the other thing to think about is, you might be thinking, what about where the derivative does not exist? Well, that would be where this equals 0, and I'll just tell you that that doesn't, I don't know if it, I'm thinking it comes out, be where that equals 0. I think this comes out, you can check me, but I think this comes out to be, it's where, got too far over. D prime does not exist. Square root of 10x squared minus 44x plus 50 equals 0. I think that doesn't have any real solutions. So anyway, this part of it really doesn't come into play. This is it. Find the point on the line. Okay. This is the x value that answers our question. And what was the question? The question was, find the point on the line closest to 1, 2. Well, the x value of the point is 11/5. What else do I need? I need the y value, don't I? How do I get the y value for this point? So the x is 11/5. The y value would be 3x minus 5, right here. So it would be 3 times 11/5 minus 5. Well, that's 33/5 minus 5. Let's see, 5 is 25/5, so that's 8/5. So it's 11/5, 8/5. And that looks to be about, 11/5 is 2 and 1/5. So yeah, that seems to be right there. Okay. Similar one. This next one is a similar one. Okay. Find the point on the curve. Y equals square root of 16 minus 2x squared. That is farthest away from the point 1, 0. Well, we could draw it, but it's the same thing. I want the farthest distance between, there's this curve, so the xy, I want the xy point that is farthest away from 1, 0. So again, the distance that I want is the distance between points. So I'm going to take the distance of this point from that point, so that would be, the x1 minus x2 squared plus, same thing, same formula. The x1 is going to be x, the x2 is 1. The y1 is y, minus the y2 is 0. And notice that y minus 0 is just y squared, isn't it? Okay, I want to maximize that farthest, maximum distance. What do I need to do? Well, I need to get rid of this y. How do we get rid of the y? Well, y equals this, square root of 16 minus x squared, so I'm going to replace y by 16, square root of 16 minus 2x squared. And again, I want to square this out. X minus 1 twice, so that would be x squared minus 1x minus 1x minus 2x minus 1 minus 1 is plus 1. But something real nice happens right here, doesn't it? What happens right here for the y's? Yeah, the square root and the square cancels out. That's just 16 minus 2x squared. So D winds up being the square root of, was that minus x squared minus 2x plus 17. With me? Or, for purposes of derivative, minus x squared minus 2x plus 17 to the 1/2 power. I want to maximize it, so that's at the critical number, so I need to do the derivative. The derivative would be 1/2 times chain rule, so it would be minus x squared minus 2x plus 17. The minus 1/2 times the derivative of the inside would be minus 2x minus 2. But if you rewrite that, put that on the bottom, this will be on the top. The only thing that comes out worth anything, if you will, is just where that equals 0. And like we said, multiply both sides by that or whatever, cross multiply, it just winds up being this, the top equals 0. So move that, so we have 2x equals negative 2, divided by divided by 2. The x is negative 1. So the only thing to finish it out is I need the point, the x comma y. So the y value, the y would be the square root of 16 minus 2 times negative 1 squared.